Now let us discuss the 86th question. In which case a change in entropy is negative? They ask that change in entropy, that means delta S is equal to negative among the four options. We know that entropy means the randomness or disorder present in the system. We know that gases have high entropy than liquids. Liquids have high entropy than solids. Solids having the low entropy value. Why? Because they are arranged in an close packed structure. Gases is highest entropy value. Why? Because there is an increase in randomness or a disorder in the system. Now let us verify the given statements. The first one is evaporation of water. That means liquid when heated, evaporation takes place. Evaporation, evaporation means gas. Here liquid to gas conversion. That means gases have the high randomness. So its value is delta S equal to positive. Why? Because the randomness is increased liquid converted to gases. Okay. Now let us verify the second statement. Expansion of a gas at constant temperature. Gas is expansion takes place. That's why its change in entropy. That means the randomness increases. Delta S value becomes positive. Now let us verify the third one. Here sublimation of solid to gas. Here solid is converted to gas. That's why here change in entropy will also be increases. Its value becomes delta S equal to positive. Now let us verify the option 4. Here two hydrogens, individual hydrogen gas molecules combines to form the H2 molecule. Here in individual, its randomness is very high. Its randomness or disorder is high. It combines with another mole of hydrogen gas to form hydrogen molecule. In molecule, the randomness is decreased by two hydrogen gas to form the hydrogen gas molecule. Its randomness is decreased. That's why delta S value becomes negative. So according to the question, option 4 satisfies the given question. So our answer is 4 is our correct answer. Now let us discuss 87. Which of the following series of transitions in the spectrum of hydrogen falls under the visible region? Among the four transitions, which series falls under the UV region? Okay. This is a conceptual question. We know that Pascan and bracket series falls under IR, infrared, whereas Lyman series falls under UV region, ultraviolet region. The third one is Balmer series. It falls under the visible region. So according to the concept, visible region falls under Balmer series. So our answer is 2 is our correct answer. Now let us discuss 88th question. The method used to remove the temporary hardness of water. Among the four methods, which method is used to remove the temporary hardness of water? We know that there is two methods to remove the temporary hardness of water. First one is boiling. By boiling, the temporary hardness of water is removed. The second one is Clerk's method. In Clerk's method, to remove the temporary hardness of water, quicklime is added. Okay. Now let us see the methods to remove the permanent hardness of water. The first method is Kalgan's method, and the second method is ion exchange, and third one is synthetic resins method. Now let us verify the first option, Kalgan's method. We know that Kalgan's method is used to remove the permanent hardness of water. So option 1 is eliminated. Ion exchange method is also used to remove the permanent hardness of water. Option 3 is eliminated. Option 4 is also eliminated. Why? Because synthetic resin method is used to remove the permanent hardness of water. The remaining option you have is option 2. Kleck's method is used to remove the temporary hardness of water, and by boiling to remove the temporary hardness of water. Now let us discuss the 89th question. Which one is malachite from the following? Among the four options, the formula of malachite is, we know that malachite is an ore of copper. Its color is green color with formula CuCO3 CuOH twice. So our answer 4 is our correct answer. Let's discuss 90th question. The correct order of the basic strength of methyl substituted amines in aqueous solution is. Here they are asking that among the given four options, which one is the highest basic strength in aqueous solutions? We know that basic nature means the donating ability of an nitrogen. Here lone pairs donating ability. We know that in aqueous solution, three factors are affecting the donating nature of amines. The first one is electron donating, that is plus psi inductive effect. The second one is solvation effect, that is a hydrogen bonding. The third one is steric hindrance. Firstly, draw the structures of primary, secondary, tertiary amines. Here, CH3 bond NH2 containing two lone pair of electrons. This is primary amine. Secondary amine structure is CH3 bond nitrogen bond hydrogen bond CH3. Here presence of two lone pair of electrons. This is called secondary amines. The tertiary amine structure is CH3 bond N, two lone pair of electrons, bond CH3 bond CH3. This is called tertiary amines. When you observe the structures of primary, secondary, tertiary amines, we clearly conclude that tertiary amines having the steric hindrance. That's why the lone pair donating ability decreases. By know this point, you can easily eliminate option 2 and option 3. Due to the presence of steric hindrance, the tertiary amines donating of lone pair of electrons decreases. But in primary amines, after donating its lone pairs to others, the positive charge is neutralized by solvation effect, that is hydrogen bonding. So the donating ability of primary is greater than tertiary. When you compare the primary and the secondary is higher donating ability. Why? Because of higher solvation effect. So we conclude that its order is secondary greater than primary greater than tertiary. Now let us verify the given options. Here primary greater than secondary greater than tertiary. Option 4 is also eliminated. Here you have left with option 1. It has secondary greater than primary greater than tertiary. Secondary, primary and tertiary. So option 1 is our correct answer.